Hello everyone. I am going to do one more problem in Raabe's test. How to identify whether we have to apply Raabe's test or not, I will tell you. Test the convergence of the series sigma 4 into 7 into 10 and so on 3n plus 1 by 1 into 2 into 3 and so on n into x to the power of n. This is the given question. To do this problem, we cannot apply Raabe's test beginning itself. Whenever the ratio test fails, then only you have to apply Raabe's test. That means you have to apply first ratio test sigma un. Given series, always you have to take it as sigma un 4 into 7 into 10 into and so on 3n plus 1 by 1 into 2 into 3 and so on n into x to the power of n is the given series. To apply ratio test, we need un plus 1. un plus 1 is equal to, wherever n is there, in place of n in place of n you have to substitute n plus 1. 4 into 7 into 10 and so on 3 into n plus 1. 3n plus 3 plus 1 is 3n plus 4 by 1 into 2 into 3 and so on in place of n plus 1 into x to the power of n plus 1. This is the nth term. Ratio test formula. Limit n tends to infinity un by un plus 1 is equal to limit n tends to infinity un. How much is our un? 4 into 7 into 10 into 3n plus 1 by 1 into 2 into 3 and so on n by un plus 1. If you write this big fraction, it will become reversed. 1 into 2 into 3 and so on n plus 1 by 4 into 7 into 10 into and so on 3n plus 4. For un it is x to the power of n is there. X to the power of n is there by if you write it will become reverse, that is equal to, you will get in the denominator 1 by x to the power of n plus 1. X to the power of n get cancelled. The previous term of n plus 1 is n. The previous term of 3n plus 4 is 3n plus 1. Why? Because the difference between any two numbers is 3. The difference between any three numbers is 3. That's why the previous number of 3n plus 4 is 3n plus 1. Now 3n plus 1, 3n plus 1, 4 into 7 into 10 and so on 3n plus 1 get cancelled. 1, 2, 3 and so on n. 1, 2, 3 and so on n get cancelled. The remaining is limit n tends to infinity. X to the power of n get cancelled. You will get the remaining is n plus 1. Here n plus 1 is there by 3n plus 4 into 1 by x. X to the power of 1, x to the power of n plus 1, x to the power of the power itself n plus 1 is there, n by x, you will get 1 by x. Now taking common, limit n tends to infinity, n common 1 plus 1 by n by 3n common 1 plus 4 by 3n, n cancel into 1 by x. If you apply the limit 1 by 3 into x, if you apply the limit 1 plus 0, 1 by 3, that is equal to 1 by 3x. You will get the value as 1 by 3x. Now by ratio test, we have to write the conclusions of ratio test. By ratio test, if 1 by 3x is greater than 1, sigma un is convergent. What is the meaning of this? 1 by 3x is greater than 1 means if you cross multiply 1 greater than 3x. That means 3x less than 1, x less than 1 by 3, sigma un convergent. From this only, by ratio test 1 by 3x, we have got the answer as 1 by 3x. What we are doing with the 1 by 3x? 1 by 3x greater than 1, convergent. If you cross multiply, 1 is greater than 3x, implies 3x is less than 1. 3x is less than 1, so if you send the 3, x is less than 1 by 3, sigma un is convergent. And another conclusion is 1 by 3x is less than 1, then sigma un is divergent. 1 is less than, if you cross multiply, 1 is less than, if you cross multiply, 1 is less than 3x. That means, implies 3x is greater than 1, implies x is greater than 1 by 3. 3x is greater than 1. I am writing in order. 3x is greater than 1, then sigma un is divergent. Divergent, dgt means divergent. The conclusions, what I am writing, 1 by 3x is greater than 1, convergent. 1 is greater than 3x. If you cross multiply, 3x is less than, in other words I wrote 1x less than 1 by 3, sigma un is convergent. First conclusion. Now 1 by 3x is less than 1, divergent. Then if you cross multiply, 1 is less than 3x. 3x is greater than 1, implies x greater than 1 by 3, sigma un is dgt, divergent. When x is equal to 1 by 3, the test fails. If x is equal to 1 by 3, the test fails. Now if x is equal to 1 by 3, what will happen? We have to see. That means the further investigations we have to do when x is equal to. Now here we wrote all the conclusions. If x less than 1 by 3, convergent, we have got conclusion. If x greater than 1 by 3, we have got sigma un is divergent. We have got such type of conclusions when less than 1 by 3, greater than 1 by 3. When x is equal to 1 by 3, the test fails, we are telling. Now whenever the test fails, what will happen? We have to see. That means we are doing further investigation whenever the test fails. When x is equal to 1 by 3. When x is equal to, we are in which case? X is equal to 1 by 3. Sigma un. Where is sigma un? In this, the sigma un I will give you, I will write from the given sigma. This is sigma un. 4 into 7 into 10 into 3 and plus 1. This is the sigma un I am writing. The sigma n I am substitute. This is sigma un. Given sigma un I wrote. I will substitute x is equal to 1 by 3. X is equal to 1 by 3 whole to the power of n. Now I will apply Raabe's test from here. Now if you observe sigma un, it is not possible to choose sigma vn. Whenever the ratio test fails, whenever the ratio test fails, you write down sigma un. By observing sigma un, if it is possible to choose sigma vn, you have to apply comparison test. If it is not possible to choose sigma vn, then you have to apply Raabe's test. Now if it is not possible to choose sigma vn, that's why I am applying the infinite number of values are there. That's why I am applying Raabe's test. What is the formula of Raabe's test? Limit n tends to infinity n into un by un plus 1 minus 1 is equal to limit n tends to infinity n into un by un plus 1 from the previous term. Un by limit n tends to infinity un by un plus 1. Before taking common whatever the term is there, that term we should write n plus 1 by 3n plus 4 into 1 by x. N plus 1 by 3n plus 4 into 1 by x. 1 by 3. 1 by x is there here. 1 by x is there in place of x. If you write 1 by 1 by 3, 1 by 1 by 3 is nothing but 3. Minus 1. That is equal to limit n tends to infinity. If you multiply with the 3, 3n plus 3 by 3n plus 4 minus 1 is equal to limit n tends to infinity. LCM n into outside 3n plus 4, 3n plus 3 minus LCM is 3n minus 4. Limit n tends to infinity minus 1 by n into 3n plus 4. Now taking common n into minus 1 by n common, 3n common, 1 plus 4 by 3n, n cancel. Apply the limit minus 1 by 3. If you apply the limit minus 1 by 3 into 1 plus 0, that is equal to minus 1 by 3, which is less than 1. By Raabe's test, sigma un is, whenever it is less than 1, it is divergent. Sigma un is divergent. Now we have to combine all the conclusions. Now the conclusions, how to combine the conclusions? Now see the first conclusions. When x less than 1 by 3, sigma un is convergent. In case of and x greater than 1, it is divergent. Therefore, I am combining the conclusions. If x less than 1 by 3, sigma un convergent. If x greater than or equal to 1 by 3, in case of greater than 1 by 3, it is divergent, as well as in case of x is equal to 1 by 3, in case of x is equal to 1 by 3 also we proved it is divergent. That's why x is greater than 1 by 3, sigma un is divergent. This is like this. You have to combine both conclusions and write. Thank you very much.